just continuing on with the idea about quadratic. So our quadratic function, of course, y equals x squared. Now, first of all, we know the linear function together with the quadratic function, actually every polynomial can be factorised down to one of those two things. So they become two very important functions that we look at. So just like the straight line, the basic one, y equals x, our y equals x squared is the basic one, and we can turn it into any other parabola using translations, rotations, reflections, and so on. How do we recognise it? Well, there's our general quadratic, ax squared plus bx plus c. And basically, we're just looking for one of the pronumerals being to the power of 2. I mean, we recognise it's a quadratic, therefore the picture will be a parabola. Some different ideas about how to find information with quadratics. First one is that completing the square idea that we saw when we were solving quadratics. If I complete the square on the quadratic, I could rewrite it to be this form. So y equals ax minus h squared plus some constant. Now, when it is in that form, I can read off straight away what the vertex is. So the h value there would be the x value, and the constant would be the y value. So one way of finding the vertex. A, of course, still measures the concavity. Okay. Same question as yesterday, so sketch the parabola, although I'm not actually going to draw it again. But if I had to find that information, but I decided, oh no, I'm going to approach it by using completing the square instead. So I've got y equals 8x plus 12, or x squared plus 8x plus 12. I know that when this is factorised as completing the square, I'll end up with x and then half the coefficient of x squared. So I know I will end up with x plus 4 all squared. But of course, when I expand that out, I don't get 12, I get 16. So to make it correct, I have to subtract 4. But now it's in that form, I can read straight off it and go, okay, the vertex is negative 4, negative 4. If I wanted to find the x-intercepts, well, now that I've got it in the completing the square form, I could just say, well, x plus 4 squared minus 4 is equal to 0. Move the 4 over. Something squared is equal to 4, so it must be equal plus or minus 2. Move the negative 4 over, and I get the two x-intercepts. Now, I've had a question like this. Same question again as yesterday. We said, write down the quadratic whose roots are 2 and 8, and the vertex is 5, 3. Well, because they've told me the vertex is 5, 3, I know I should be able to factorise it into this form. Some constant times x minus 5 all squared plus 3. Now I've put the braces around here just to highlight, see the general form here. The constant is only times the perfect square. It's not times the plus 3 part when we're writing it that way. I can sub in, well, either root, it doesn't really matter. And we can work out what k is. So I used 2 naught, but as I say, you could have just as easily used 8 naught. Sub that in, and eventually we get negative 1/3, and you'll see we get might not look like it at this stage, but that's the same answer as yesterday. And to prove it is, we could expand out and group like terms, and we'd end up with the same answer as yesterday. So that's one different way of finding the information. There's another different way as well, using the thing we call the discriminants. Now the discriminant, its symbol is a delta, and it's basically b squared minus 4ac, which you might recognise from the quadratic formula. It's the bit under the square root sign. The vertex, the x value of the vertex, as we know, is the axis of symmetry. It's minus b on 2a. The y value of the vertex will always be minus the discriminant on 4a. So this is useful, I guess, if you've got a question which simply says what's the maximum or what's the minimum. So all we're really interested in is the y value. I don't have to go and find the vertex and sub in. I can just go, oh, well, it's minus the discriminant on 4a and work that out. Our zeros then, well, it's our quadratic formula, but instead of writing b squared minus 4ac, I've written delta for the discriminant. Now, it also tells us some other information. Because delta is this bit under the square root sign, and we know we can't find the square root of a negative number. So if that turns out to be less than 0, we know there's no x-intercepts. Or if I'm trying to factorise it, we know it can't be factorised, because I wouldn't have got any solutions. If it turned out to be equal 0, then I know there's just one x-intercept. Well, that means it's a perfect square, because it's just going to come down and touch the x-axis rather than cut it. And if it's greater than 0, then we know, yes, there will be two solutions. It can be factorised, and we'll get two x-intercepts. Okay, back to the same question again. So if I'm going to approach it using the discriminant idea, well, we can work out our discriminant, b squared minus 4ac, 16 in this case. So my vertex minus b on 2a will be the x value, minus the discriminant on 4a will be the y value, and sure enough we get our answer of minus 4 minus 4. Sometimes you might use a combination of the ideas. You might use completing the square for one thing, you might use discriminant for the other, and it's totally up to you. It just gives us alternative ways of finding the pieces of information.